So I can directly put the data set I'm collecting. So here, after this general description of the problem, we were focusing on this correlation about visibility condition and walking speeds. And currently we have these two data sets that are quite different and are based on different experimental conditions. And these are the first one is the Jeans experiment that were performed in the 70s, and the more recent one that were performed by Francis and Nilsson in a set of previous experiment they did like 5-6 years ago, something like this, in tunnels. So what are the differences in these data sets? Actually, we are using these data sets as equivalent if you are a modeler sometimes, but they are based on completely different experimental conditions, so users should be aware on the genesis of this data set. And here we see that, for example, from this graph, we have different types of extinction coefficients that were investigated into two sets of experiments. You see that the black spots are the Jeans one, and in the Lund dataset we have a broader range of extinction coefficients. And also the type of population was different, because in the experiments of Lund University we have pretty much only Swedish students, while in Jeans experiments we have two categories, students and non-white, so we have a broader range of population. And also the smoke irritancy, because in Lund experiments they were using artificial smoke, coal smoke, and acidic gases for simulating the effect of irritant gas of a fire. While in Jeans experiments, it was using two different kinds of things for producing the irritancy, using kerosene or using wood ribs. So, and also the layout itself was different, because in Lund experiment we had a tunnel, approximately 30 meter long, and in Jeans experiment was a bit shorter. So after having described the data set that we have at the state of the art, so now we were testing different models and see what choosing from which models that we're using these different data sets in different ways, so belonging to the three categories we were discussing before. So EVAC, we have FDS EVAC, which is using now the Francis and Nilsson's dataset, and it's a single factor setting we have there, but being an open source model in theory, we can still change whatever we want, because we have the full control on the model. So we have everything is open, so we can play with the model as we want, because it's an open source model. Building Exodus, that is a single factor setting, that is the Jeans dataset, so the other dataset, and this is a closed source model. So if we want to use something that is different, a different condition, we should use our expertise for simulating a different impact of visibility condition and speed. And finally, we use grid flow, the model from Professor Kurser, that it's, from this point of view, is pretty strong, because we directly input, we have no default settings, so it needs a degree of expertise higher from users, but it permits to implement whatever kind of correlation we want, because you have to insert a spreadsheet in which you say the impact on walking speed of certain visibility conditions, and also you can play with the susceptibility of that impact on different people. So after describing how the three models tackle this problem, we have selected a number of scenarios, 50 scenarios, in which we were trying to cover a good range of possible initial walking speeds and different extinction coefficients, ranging from, for walking speed, from 0.25 to 1.25 meters per second, and for extinction coefficients from 0.5 to 10. And we were trying to keep constant all the other values that were not related they were not strictly related to this problem. So here you have the assumption we were using. So we configure the models in a way, I will not go very much into that, how we configure the model, but we did it in a way to following the assumption we were saying. And we also made end calculations for making a sort of verification test, a test that how the way the model was using that correlation was in line with the end calculation with we were doing. So, and we verified actually that the models were working in line with our calculations. And then using the Jeans curve with the range of the range that is range of applicability. And so I will skip to the results. And here we have the results. So we saw that when we use the same data set, in this case Fancy and Nielsen data set, we get exactly the same results. Here we are comparing, FDS, EVAC, and grid flow using the same data set, low data set for one of the scenarios, and for different extinction coefficients and different evacuation and different initial working speeds. And when we were using two different data sets, we were getting completely different results. So what I want to point out here is that are engineers aware that if they tackle the same problems with two different models that are considered as good models, they are getting completely different results just using two different data sets. So when they're using this default in, for example, in Exodus and Balloon, in which you have this correlation already built in within the model, it's embedded in the model, are they aware that you will get this huge difference? And we get this for different type of scenarios with differences in relation to the type of irritant gas or non-irritant gas we were getting. So my conclusion is that we were getting different results when applying different data sets, and we were getting the same result when we were using the same data set. So the point is how the users are aware of this. Are they making some thought to try to solve this problem? Or we know that the state of the art currently is giving us just these two correlations, but they are in completely different, we saw in completely different conditions where these experiments were done. So if you know your scenario that you're going to simulate, maybe you need also to think what could be the best model, the best experimental data set that you should use for address that specific scenario that you are considering. Also, when we analyze in depth this experimental data set, we saw a great spread in the results. The results are always very scattered, and we use normally this correlation with average, like average values and